In this video, we want to learn how to solve exponential equations. Now, some of them are relatively easy. You can probably do without anything before this class. 2 to the x is equal to 8. If we were to look at this, we know the answer is supposed to be, of course, 3, because x to the third is equal to 8. Relatively simple because there's a whole value and a small base. If we were to take something like 3 to the x is equal to 8, that's not nearly as simple. X to the first is only 3. 3 to the first is only 3. 3 to the second is it's already 9. So we're going to need something between 1 and 2. So how do I get there exactly? Well, in order to solve these exponential equations, we're going to have to use logarithms. So we can actually do this with what we know about logarithms. I know that to convert to logarithmic form, I can take log of whatever my base number is, log base 3, of whatever is on its own side, so that 8. And logarithm always gives me my exponent. That's what a logarithm does. The logarithm spits back out the original exponent from the problem. Logs equal exponents. Now once I have it in a form like this, I have solved for that exponent, but if I look at the calculator can only do log base 10, the standard log, and log base e, the natural log, the ln. We only see the log and natural log. If we try and type this thing in, log 3, 8, the calculator is not going to read that as log base 3 of 8. It's going to read it as log 38. Even if we were to use parentheses there, no good. So we have to figure out a better way to put in the calculator, or a different way to put in the calculator. The way we're going to do that is we're going to use a change of base we looked at in the last section. Change of base, remember, let's think about what that looks like. Log base b of x equals log of x over log of b. And really this changed it to any base we wanted to. We call it log base y here. But we're going to be wanting to use those, either the standard log, log base 10, or the natural log ln, because that's what the calculator can do. Remember, the easiest way to remember this, remember which one goes on top. I'm going to draw a line right through the center of that log. Half the log comes on top as log x, half the log b on the bottom. So for this one, we'll have log of 8 over the log of 3 equals our x. So we'll need to pull out our calculators. We'll type this in. And what we should get, we'll jump up over here. We will have that x, we get 1.8927. Go out a couple more decimal places, 8, 9. It keeps going, of course, too. We should see tons of decimal places if we had a really precise calculator. Now we're going to round our answers anywhere from 2 to 6 decimal places, depending on how small these answers are and whatever the problem tells us to. So in this problem, I didn't specify. Let's go ahead and see what it would look like to 4 decimal places as well. We can see, because it's just such a small number, 1.8928, we'd probably want to round it pretty far out so we get a pretty precise idea of what the answer is going to look like. Now, I said we could use either log base 10 or log base e to solve these. So let's see how we could have done the same problem, but instead of converting to log base 10 as we did right here, let's convert it over to log base e, or the natural log. So we'd have natural log of 8 over the natural log of 3. If we type that in the calculator, we get back to these same exact answers. Next, I want to look at another exponential equation. Let's say we have 2 to the x equals 3 to the 3x minus 1. Now we've gone into something that's quite challenging, right? There's no way for us even just to keep trying decimal places at the same time. That would just take forever. So we really want to have a method to solve this. We want to use our logarithms. Now, that last problem, we could have thought about this as the same way. We have the fact that whenever we want to, we can take the log or the natural log of both sides of an equation. As long as we apply a function to both sides of an equation, we can do that. And what's the benefit to this? Well, whenever we have logs or natural logs, we can take that exponent, we can bring it down to the front of the equation. That was our power rule. So we can rewrite this x ln of 2 equals 3x minus 1 ln of 3. And now we've taken something that was in exponential form, and it's really in linear form at this point. ln of 2, we could plug that in the calculator. That's just a number. Ln of 3, same idea. That's just a number. So we can take any number and always distribute it through a parentheses. So I'm going to take this ln 3, distribute it through the 3x and the 1. I'll leave that x ln 2 alone for a second. So I'm going to spread this out. Of 3x ln 3. And that was supposed to be minus. My minus didn't come through great. Minus ln 3. Just like with any other equation, I want to get my x terms to the same side, so I'm going to subtract this 3x ln over to the other side. Subtract that to both sides, so subtract it over here. So I'm going to have is x ln 2 minus 3x ln 3 minus ln 3. At this point, I can pull out an x from both here and here from both this equation and this equation. So I'll have x ln 2 minus 3 ln 3. That was an equals. And that should have been a negative natural log of 3, because we have a negative from right here. Negative natural log of 3 on the right hand side. At this point, our last step is to divide by everything in parentheses. So I'm going to divide this by natural log of 2 minus 3 natural log of 3. We're going to type this thing right here in our calculator. When we do that, I'll stick my answer up here in the corner here. And in green, we get 0.4221. And that continues out, of course, 0.6521116, keeps going. And so we get to our answer. So we started this problem up here. We said, well, in order to get those exponents to the front, we're going to need to take the log or the natural log of both sides. That's what allows us, once we have a log, we're allowed to bring those exponents to the front, as we did here and here. Then we distributed our ln 3 through, and so we had 3x ln 3 minus ln 3. And then we moved our x terms to the same side by subtracting on both sides of the equation. And then finally we factored out the x so that we could divide off everything that wasn't the x. We typed in negative natural log of 3, divide by natural log 2 minus 3, natural log 3. Now it is important to keep in mind, everything in that denominator needs to be in parentheses. Calculator doesn't recognize when you have a fraction when you don't, so make sure you keep everything in parentheses.